Okay, super quick lesson today. Mainly we're just going to be applying two new definitions to some practice problems that are similar to what we've already been doing. So the two terms we've got are angle of elevation and angle of depression. And really they're just terms that they use to describe angles when you're trying to, in like a word problem, when you're trying to describe a situation. So elevation means just that. It's the angle formed by a horizontal line and the line of sight to an object above. So if we have a horizontal line like we have here, and there's an angle above, that's going to be our angle of elevation. Think, looking straight ahead, and then the angle that you tilt your head upwards to look at something above your horizon, that's your angle of elevation. Right? Think elevate, lifting up. And then angle of depression is just the opposite. So if you're looking straight ahead off into the horizon and you tilt your head downwards to look down, that's your angle of depression. So it's the angle formed by a horizontal line and the line of sight to an object below the horizon. So starting again with our dashed horizontal line here, if you measure an angle down from that horizontal line, that angle there is your angle of depression. And really they just want you to understand these two terms because they use these often in word problems when dealing with right triangles and trig functions and things like that. So let's look at a couple examples we have here. This first one just wants you to identify the angles of elevation and angles of depression for each situation. So it says one side of the angle of depression is a horizontal line. So it says angle 1 is the angle of, so if we look at angle 1 here, if we look at it starting from this horizontal line, this angle is measured below the horizontal line, so that would be the angle of depression. Now oftentimes they'll give additional descriptions, right? So angle of depression from the airplane to the building. So we're starting from the airplane and we're looking down at the building. And then it says one side of the angle of elevation is a horizontal line. Angle 2, so here's angle 2, and notice we're using that same line from the plane to the building, but now we're starting at the building and looking down. So this is the angle of elevation because here's our horizontal line and this line is above it, so we're measuring the angle above it, so that's elevation, from the building to the airplane. So we're starting horizontal line of sight from where we would be standing on the building, and angle of elevation looking up. So if we were to continue naming these, we could name the angle of depression from the building to the person, or the angle of elevation from the person to the building. So notice how they kind of come in pairs. If you're looking from one object to another, you can either look at this as being angle of depression from the plane to the building, or angle of elevation from the building to the plane, angle of depression from the building to the person, or angle of elevation from the person up to the top of the building. So now that we have those straight, let's use what we learned in the last two lessons when we learned our tangent, sine, and cosine, and some of these terms, and we can put it all together. So it says a surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite, which is it's a measuring tool that surveyors use. You've probably seen them with the little tripod and everything. So the angle of elevation to the top of the building is 35 degrees. So if we're doing angle of elevation, that means horizontal line of sight, and we're measuring the angle up. So here's our theodolite, horizontal line of sight, and the 35 degrees up because it's angle of elevation to the top of the building. So they want to know how tall the building is, and then it says use a diagram to represent the situation. So here they've drawn out a diagram. We've got this 5-foot theodolite, and now we can look at this triangle here because they give us this 35 degrees, and we know that buildings should be straight up and down usually, so that's going to be a right angle with the ground. And so we're trying to find x. So if we have an angle, and we also know that this theodolite is 200 feet from the building, we have an angle and we have one of the sides, so we should be able to use our trig ratios to find out the other side. In this case, notice if our angle 35 is here, we have the adjacent side is 200, and the x that we're trying to find is the opposite. So we need to think to ourselves, okay, so ka toa, which one of our trig functions involves the adjacent and the opposite side? And that would be tangent, right? Toa. Tangent is opposite over adjacent. The other two, sine and cosine, both involve the hypotenuse, which we don't have any information about. So we'll use tangent, and remember it's always tangent of an angle. Right? This value in the tangent function is always going to be an angle. Always, always, always. You're never going to put a length inside the tangent. It's always going to be an angle in there. So tangent of the angle, in this case our angle is 35, is equal to, remember we said the tangent ratio is opposite over adjacent. In this case our opposite value is x, opposite from this angle, and adjacent is 200 down here, so opposite over adjacent, and then we just solve for x, right? So they multiply both sides by 200, and we get x equals 200 times the tangent of 35. Note, you cannot multiply 200 times 35, then do the tangent. Okay, think of this as having, we can think of this as always having brackets. I actually prefer to write it that way. Right? So I always draw brackets around my angles. That way I know that I have to do the tangent of 35 first, then I can multiply by 200. But you cannot do 200 times 35, then take the tangent. Punch that into our calculator. If you punch it in this way, it should take care of it for you. It'll do the tangent, then multiply by 200, and we get an answer of 140 point so on. So we can round that to 140. Now, we're not quite done. They want to know how tall the building is. We've found this length here based on this right triangle, but remember that the theodolite is actually 5 feet in and of itself. So we have to add that 5 feet on there. So the building is going to be 140 plus the additional 5 feet, or 145. Alright, moving on with our last example, and then we'll be done. Here we're doing aviation. Notice they've got our plane, horizontal line of sight. It says it's flying at 3,500 feet above the ground and begins a descent, or a 2-degree descent, to land at the airport. How many miles from the airport is the airplane when it starts to descend? So notice it says it's 3,500 feet high. Always draw a picture. It's just going to be much easier. 3,500 feet in the air. It starts a 2-degree descent, meaning angle of depression is going to be 2 degrees. And they note that it's not drawn to scale. I think we can pick up on the fact that that's not a 2-degree angle. And they're trying to find how many miles from the airport is the airplane when it starts its descent. So from here to the actual airport, we're trying to find this length x. So notice here we've got ourselves a right triangle. That's why you draw the figure. Once you start putting pieces of information in there, usually you can pick out the right triangle. Our right angle is going to be up here. So notice we have our angle, and this time we have the opposite side, right? So 3,500 feet would be opposite from this 2-degree angle. So we have the opposite side, and we also are trying to find the hypotenuse. So again, we need to go back to our trig function, so, ka, toa. Which one includes opposite and hypotenuse? And that would be the sine ratio, right? So, SOH, sine, is opposite over hypotenuse. So again, it's always going to be sine of an angle, tangent of an angle, cosine of an angle. So in this case, our angle is 2. So we have sine of 2. And again, if it helps you, you can throw brackets in there just to remind yourself that you've got to complete that before you do any multiplying. So we've got sine of 2 degrees equals opposite, which is 3,500 feet, over hypotenuse, so 3,500 over x. And then if we're going to solve for x, we need to get it in the numerator, right? So x moves over to the other side. If we multiply both sides by x, x moves over to the other side, and then we can divide by sine of 2 degrees. If you want to look at it, if you have trouble solving that way and you want to look at this as sine of 2 degrees over 1, then you can cross multiply. So you get sine of 2 degrees times x equals 3,500, then you divide by sine of 2 degrees. Again, you cannot multiply the 2 and the x You have to take the sine first. Anyway, we end up getting 3,500 over sine of 2 degrees. Punch that into our calculator, get an approximation, and that gives us a value, but notice they say how many miles, and here we were using feet. So our answer comes out in feet, right, over 100,000, but then we divide by the conversion between feet and miles, 5,280 feet in a mile, so we divide by 5,280, and we get just about 19 miles. Alright, so that'll wrap it up. Again, this was short, just learning a couple new terms, but they're important for solving a lot of these trig type word problems because it helps you to understand the situation that's going on. So work through the quick checks, make sure you finish those, and also in class you're going to work on the practice 8.5. Alright, see you soon.